Okay, good afternoon. This is the Unit 3.2 review, and right now we're going to do the first section which asks us to solve by graphing. So the first step we do is identify our a, b, and c value of this function, and my a value, which is the number in front of x squared, is -1. My b value in front of x is -2, and my c value is 8. Now, if a is positive, the graph is going to open up. So if a is greater than 0, it's going to open up. If a is less than 0, my graph is going to open down. So here a is less than 0, so this graph is going to open down. Okay, the equation of axis of symmetry is x equals -b over 2a. Okay, so we're going to plug in -2 for b, so it's -2 over 2 times a, which is -1. This becomes a +2 over -2, so x equals -1 is my equation of axis of symmetry. For my vertex, for my x value, I go ahead and bring down the -1. And to get the y value of my vertex, I just plug it into the original function. I plug in my x value into the original function, so I'm going to have -1 squared. And make sure you use parentheses, because when you're squaring a negative, it can get kind of tricky in the calculator, so always use your parentheses correctly. -2 times -1 plus 8. I'm going to go ahead and take a second and enter that in my calculator. And remember, I'm going to use my parentheses correctly. So I type in negative, open parentheses, -1 squared, and I forget what I was doing. So it's -2 times -1 minus 2 times -1 plus 8, I believe. Yep. Hit enter, and that's going to give me 9. So my y value of my vertex is 9. Okay? If my graph opens up, it's going to have a minimum value. If my graph opens down, it's going to have a maximum value. So here my graph opens down, so I'm going to have a maximum value. And it's going to always be this y value of my vertex. So my maximum value here is 9. The coordinate of my y-intercept is always 0, c. So here it's going to be 0, 8, because my c value is 8. Now I can go ahead and start graphing. And the way I do this is I always do my 1, 3, 5 rule, and I multiply it by my a value. Here my a value is -1, so I'm going to multiply each number inside the parentheses by -1, so it's going to be -1, -3, -5. So I start by plotting my vertex, which is -1, 9, so I go over -1, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's my vertex. And then I'm going to go over 1, down 1. So over 1, down 1. And that's the point at which my graph touches the y-axis. And so we can double check this and count and see if my y-intercept is here at 0, 8. And we'll check 0, 1, 2, 3, 4, 5, 6, 7, 8. And it is. So we are correct in that sense. And now I'm going to go over 1, down 3. And then over 1, down 5. 1, 2, 3, 4, 5. Remember, I'm going to require that you plot at least 5 points. I want at least 5 points. And I do the same thing on the other side. I went over 1, down 1, over 1, down 1, over 1, down 3, over 1, down 5. And then I connect these points. Please do not forget to connect your points to form the parabola. And hopefully you'll do a better job than I just did. Make it a nice even parabola. And what should happen is you should end up seeing where your parabola crosses the x-axis. Here it crosses at -4, 0, and then also at 2, 0. So those are my zeros or my x-intercepts. My domain is all real numbers, because if you look, my parabola is going to keep getting wider and wider, and it will contain every x value possible. And if they ask for an interval notation, which they do, it needs to be from negative infinity to positive infinity, which encompasses all real numbers. Now my range, so this would be my interval notation. My range, all my y values are less than or equal to 9. So the smallest value of y that I have is negative infinity, and we can never reach negative infinity, so that's why I'm putting parentheses. And then we can, because there's an equals to sign there, we put a bracket around 9, and that's my range. Okay, so let's move on to the next problem. And I always start by identifying my a, b, and c. Here my a is equal to -1, my b is equal to -8, and my c is equal to -17. Okay, my a value is less than 0, so it's going to open down. My equation for my axis of symmetry is x equals -b over 2a. So we end up getting positive 8 over 2 times -1, which is 8 over -2. So x equals -4. My equation of axis of symmetry is x equals -4. And remember, my axis of symmetry is always my x value of my vertex. I take that vertex value and I plug it in to the original function. So I have -4 squared. Remember, I'm being very careful with my negatives and my parentheses. Minus 8 times -4 minus 17. And when you plug that into your calculator, you end up getting -1. So my vertex is at -4, -1. And remember, if the graph opens down, it's going to have a maximum value. If it opens down, it's got a max value. And that value is always going to be the y value of the vertex. And it's at -1. The maximum value of this graph is -1. My y-intercept is always 0c. The coordinate is 0. My x value is 0, and my y value is -17. Okay, so once you've gone down to the y-intercept, you can come over here and do the 1, 3, 5 rule. And my a value here is -1 again. So I'm going to multiply by everything inside the parentheses by -1. And I get -1, -3, -5. So I plot my vertex, which is at -4, 1, 2, 3, 4, down 1. And then I'm going to go over 1, down 1, over 1, down 3. And then remember, I only need 5 points. So if I go over 1, down 5, it's going to be somewhere below here. Oh, whoops, that's in the wrong section. I went over 2. Somewhere right down there. And remember, I only need 5 points. So even if you just stayed on the graph, you would have had an F. Connect the dots, and it looks like a beautiful opening down parabola, and it does not cross the x-axis anywhere, so there are no x-intercepts. My domain, once again, is all real numbers, but remember, they want interval notation, so it's going to be -infinity to positive infinity, and we can never reach negative infinity or positive infinity. That's why we use parentheses instead of brackets. My range, all my y values must be less than or equal to -1. So we're going to start off by saying negative infinity is my lowest y value, and we can't ever reach it, so we use parentheses. And then we put comma -1. And remember, it can equal -1, so we put a bracket there. Okay, last one of the solving by graphing problems. And I'm going to go a little bit faster, so if you need to pause or rewind, that's okay. But, so A here is equal to 1, B is equal to -6, and C is equal to 9. A is greater than 0, so it's opening up. So we're going to write up there. My axis of symmetry is x equals -b over 2a. So x equals negative negative 6 over 2 times 1. So x equals 6 over 2. My equation of axis symmetry is x equals 3. So my x value of my vertex is 3, and I take that and plug it into my original function. So I have 3 squared minus 6 times 3 plus 9. And that's going to give me, let's check and see, 9 minus 18 plus 9, it gives me 0. So my vertex is at 3, 0. And remember, it opens up, so this time it's going to have a minimum value. And my minimum value here is going to be 0. It's always the y value of the vertex. The coordinate of my y-intercept is always 0, c. So the x value is 0, and the y value is 9, because c is equal to 9. So now I can go ahead and do my 1, 3, 5 rule. And I always multiply 1, 3, 5 by my a value, and my a value here is 1. So when I multiply those values inside the parentheses by 1, I still end up with 1, 3, 5. So I plot my vertex, which is 3, 0. And I'm going to go over 1, up 1 this time, and then over 1, up 3, and then over 1, up 5. And I'm going to do the same thing over here. I'm going to go over 1, up 1, over 1, up 3, and then over 1, up 5. And if you notice, when you connect these points, it crosses the y-axis at 0, 9, which is what we predicted the y-intercept to be. Now, there's only one point where it crosses the x-axis, and that's our vertex. So we're going to write 0, 3 as my x-intercepts. The domain is all real numbers, okay? And all my x values go from negative infinity, and they want interval notation here, so we're going to go from negative infinity to positive infinity. And the range, all my y values must be greater than or equal to 0. So we're going to go, we start, our lowest value is 0, and it can be equal to, so we put a bracket, and it goes all the way up to positive infinity, and we close with the parentheses because we can never reach negative infinity or positive infinity. Okay, so we've done the solving by graphing portion. Hopefully this is a review for you since we've had a test over this before. And now we're going to move on to the back page of our review where we're doing inequalities and application problems. So if this is a good breaking point for you, go ahead and pause this video. Okay, the directions on this part of our review says solve each inequality and state the solutions in interval notation. So what we're going to do is we're going to go ahead and go into the calculator, and we're going to enter in the left side of the inequality as one graph, and then the right side as another. So if you go to the calculator, we're going to go to a graph page. Okay, we're in a graph page. And the left side of our inequality is x squared minus 7x plus 16. So we've entered in the first set of our inequality. The next graph, we're going to hit Control G or Tab. I hit Tab to get an F2. And we're going to enter the right side of the inequality, which is 4. And hit Enter. And now you have your two graphs showing. Now we need to find the intersection points of these two graphs. So we go ahead and I'm going to zoom in so I can see my intersections a little better. And I go Menu, Analyze Graph, Intersection. I click to the left and to the right, and there's my first intersection point. And I'm going to do it again, Menu, Analyze Graph, Intersection, click to the left and click to the right. And there's my second intersection. And remember, I'm only interested in the x values, okay? And so here, what we're going to do is I'm going to go ahead and take this graph and bring it over to our review page. Just so we can be on the same page here for a second. Let's see if we can bring this up. Don't know if we can, but we can try. Sorry, y'all. Thanks for bearing with me. I think it'll make it easier if we have everything on the same page, though. Okay, so there's our graph for number 4, and we found our intersection points. Now, what I like to do is I like to sketch this graph on this sheet of my paper. So the way I would have done it is I would have just drawn a little set of axes, and I would have drawn this right here. It doesn't even matter as long as you have a decent sketch. It doesn't need to be perfect. Okay, and we are doing a greater than. So we are interested in the stuff above the horizontal line. So I'm going to shade my sticks right here. Okay, and if we know we're using sticks, we're going to have a union symbol. So I go ahead and draw my arrows out so I know that I'm talking about my x values. And we know that the solution is going to go from negative infinity to 3, okay, comma 3. And since there's no equals to sign underneath my inequality, I go ahead and close it with parentheses. And that's the first part, my first stick. And then I'm going to union it with my other stick, which starts at 4. And it's going to go all the way to infinity, because the parabola is going to keep getting wider and wider. Okay? So that would be the solution to number 4. Now let's move on to number 6. Let's see if I can delete this. There we go. Perfect. Number 6, what we're going to be doing is the same exact thing. We're going to go to the graph page, or go to our calculator, and enter in the left side of our inequality and then the right side. So we go to our calculator, and I'm going to start a new graph page. And I'm going to type in the left side, which is x squared plus 3x minus 14. Hit enter. Then to enter in the right side of our inequality, I'm going to hit tab. And I'm going to hit enter in 14, because that's the right side of our inequality. And hit enter. Now, I can't see both of my graphs, so I'm going to zoom out. I love to see both of my intersections. Okay? And then remember, to find my intersections, I do menu, analyze graph, intersection, go to the left, go to the right, and there's my first one. And I'm going to do it again, menu, analyze graph, intersection, go to the left, and go to the right. Okay, so once again, I'm going to go ahead and copy this over so we can see it on our review sheet. Let's see if we can't make this a little bit bigger. Thanks for bearing with me. Okay, so we have our graph here, and like I said, I like to sketch it off to the side. So I'm going to erase my previous graph for a second. And this is number 6, okay? So we're going to take this graph and sketch it over onto the side of our paper. So here we have our graph and our parabola and our line. Okay, and here our inequality sign says less than or equal to. So we're interested in the part below the horizontal line, our smile. And since we have a smile, we have all one, it's all together, it's all inclusive, and there's not two sections, so we will not have a union sign. And here we're going from -7 to 4. So we're going to write -7, comma 4. And here we have an equals to sign, so we're going to use our brackets. So remember, a smiley face, there's only one set that we're interested in. We're interested in all the x values of this shaded smiley face. Alright, so let's move on to number 7. Here it's saying 4x squared plus 4x minus 10. So you go to the calculator once again, same drill. Open a new graph page. And we're going to type in the left side, which is 4x squared plus 4x. I did times. Minus 10. So that's the left side of our inequality. And the right side is negative 2. So we're going to hit tab, or you can hit Control G, whichever you prefer, and type in negative 2, enter. Then we find our intersection points, menu, analyze graph intersection, click to the left and to the right. And we're going to do it one more time, menu, analyze graph, intersection, click to the left and to the right. Okay? I'm going to copy this over just so we can have it together. And you can see me sketch it. Okay, we're doing number 5 right now. Sorry, we went out of order. Okay, and so here we go. I'm going to sketch this graph off to the side, and I've got a little nice intersection here, and the inequality sign here is less than or equal to. So we're below again. We are less than or equal to again this time. Okay, and our critical value points are negative 2 and 1. And remember, we're dealing with smiley faces, so it's just going to be one set of values. And we're having equals to, so we're going to go ahead and close them in brackets again this time also. Okay, so there is number 5. And let's move on to number 7. Number 7, it's going to be the same thing that we did in 4, 5, and 6. We're going to go to our calculators, open a graph page, type in the first side of the inequality, which is x squared plus 6x plus 3, and enter. Then we're going to hit tab, enter in the second side, which is negative 2, hit enter. And then we're going to go ahead and find our intersections one more time. So menu, analyze graph, intersections, click to the left, click to the right. Menu, analyze graph, intersections, click to the left, click to the right. Okay, copy this over for you. And remember, I always recommend that you sketch your graph yourself off to the side of your paper once you have it on your calculator. Alright, so here I'm going to sketch this graph one more time. Okay, and this time we're interested in a less than, so we are going to be looking below the horizontal line, which is a smiley face. Okay, and so we're going to have one thing all together. It's going to be, there's no union sign here. And it's going to be from negative 5 to negative 1. Remember, we're looking at our x values. Or it looks like it's negative, yeah, negative 1. Okay? So, now this time, we're going to use parentheses instead of brackets because there's no equals to in our inequality sign. It's just a less than. It's not less than or equal to. So our answer is negative 5, negative 1. Hopefully, me moving around in this computer has not morbidly confused you. Hopefully it helps you seeing the calculator and all of that good stuff. Okay, 8, 9, and 10 are very similar to 4 through 7, except we are having to set up our inequalities ourselves. So, here it says Redbox is thinking of changing their nightly rental prices to increase their profits. The function P of R equals negative 1,000 R squared plus 6,400 R minus 4,400. It models the monthly profit. So that function gives you the profit of a Redbox DVD rental station. Okay, and R is representing the rental price. R is representing the rental price. For what range of rental prices does the station earn a monthly profit of at least $5,000? So we want at least $5,000. And when we say at least, we mean it must, the profit equation, negative 1,000 r squared plus 6,400 r minus 4,400 must be greater than or equal to 5,000. Okay? We want it all to be greater than or equal to 5,000. The profit has to be at least $5,000. We can divide everything by 100. So we have negative 10 r squared plus 64 r minus 44 must be greater than or equal to 50. All that does is just give us smaller numbers. It does not change our answer whatsoever. We still approach it in the same way. Like I said, it just gives us smaller numbers. Okay, now we're back to the step that we were in 4 through 7. We have an inequality and we just need to find the solutions. So we go to our calculator and we enter in our inequality, the right side. So we open a new graph page. And the right side is going to be negative 10 x squared plus 64 x minus 44. Enter. That's the first part of our equation, our inequality. And then the right side, you can either hit tab or control G. I'm going to hit tab, and we're going to type in 50 and hit enter. Now I can't see both my graphs, so I'm going to zoom out. And then that's really small, so I'm going to zoom back in onto where I can see my intersecting points really well. Okay, so now I find my intersection points. Menu, analyze graph intersection, click to the left, click to the right. Now I do the same thing for the second intersection point. I hit menu, analyze graph intersection, click to the left, click to the right. Alright, so now I have both of my points, and I'm going to go ahead and copy this over like I've been doing. Okay, so here is my graph that I'm dealing with. Well, it's being tricky with me. Sorry, y'all. Okay, so I'm going to go ahead and once again sketch this out because that's what I do. Even though I have it on my calculator, I like to sketch it out. So I have this parabola and it crosses here. Now we want it to be greater than or equal to 50. So we are interested in the line, the section above the horizontal line. Okay? And my two critical points are 2.28 and 4.12. And we're dealing with a smiley face here. It's a frown, really, but that's the same thing. It's the opposite of a smiley face. It's still considered a form of a smile. Okay? So we're only going to write it as one set. So we go from 2.28 comma to 4.12, and since there's an equals to sign, we put brackets. So what this is telling me is that for what range of rental prices does a station earn a monthly profit of at least $5,000? Anywhere from $2.28 to $4.12 will give, if they charge that for a rental price, they will get a profit of at least $5,000, anywhere in that range. Okay, so a business offers tours in Patagonia, a region of South America that includes part of Chile and Argentina. The profit, P, for X number of persons, P of X, is equal to negative 25X squared plus 1,250X minus 5,000. The trip will be rescheduled if the profit is less than $7,500. How many people must have signed up if the trip is rescheduled? So we go ahead and write out this inequality. So we're going to take the negative 25x squared plus 1250x minus 5,000. And that must be less than 7,500. Then we're going to divide both sides. We can go ahead and take this inequality and divide everything by 25 to just give us some smaller numbers to work with. So we end up with negative x squared plus 50x minus 200 must be less than 300. So remember, that won't change our answer. It just gives us smaller numbers to work with. So now I'm going to go over to the calculator and enter in the left and right side of our function. So we go to a graph page. We type in negative x squared plus 50x minus 200. Hit enter. And then you can either hit Control G or Tab. I'm going to hit Tab and enter in 300. Enter, and then we're going to zoom out to where we can see our intersection points. Then I'm going to zoom back in so I can get a better look. Okay, so now I'm going to hit Menu, Analyze Graph, Intersections. Click to the left and right. Menu, Analyze Graph, Intersections. Click to the left and right again. Okay, so now I'm going to copy this graph over. Let's see if it cooperates. It doesn't look like it's going to, but we can try. Keep trying. Okay, so I'm going to go ahead and sketch this graph out off to the side. Okay, and it says less than. So now we're going to be dealing with sticks. So I'm going to shade the area that I'm interested in, which is less than. So, and then I look at my x values of my intersection points, which are 13.8 and 36.2. Went away there. And remember, we're interested in our x values. So we're going to have two sets here. We're going to go from negative infinity to 13.8, and there's no equal to, so we're using parentheses, union, and then we're going to go from 36.2 to infinity in the second stick. Okay, and remember, since there's no equal to sign, we're using parentheses. Okay, so since we're talking about people here, we cannot talk in decimal forms. So really, what we're going to talk about is that there must be less than 14 people or more than 36 people for the tour to be rescheduled. Okay, and that's your final answer. And the reason we chose 14 and 16 is because they rounded to the nearest whole number. Okay, so let's now move on to problem 10. Okay, and in problem 10, we have, we do have a function and we do have another number, but this time we're not going to set it up as an inequality. They're talking about a human cannonball that's going over a circus tent. And they give us a function where h is the height in feet and x is the horizontal distance traveled by the performer that's in the human cannonball. So, the circus act is considered a flight path directly over the main tent. If the performer wants at least 5 feet of vertical height clearance, how tall can the tent be? So, h of x equals negative 0.007 x squared plus x plus 20. And that represents this dotted red parabola that you're seeing the performer in the picture making. And what we want to know is the maximum height of that function. And the max height is at the vertex. Okay, So we go to our calculator and we can go ahead and enter in that function. And we're going to type in negative 0.007 x squared plus x plus 20 and hit enter. Okay, and we can zoom out so we can actually see this function. Okay, and we're going to find the maximum. So we go menu, analyze graph, maximum, click to the left, click to the right. Okay, and the maximum height here is 55.7. Remember, our y value is our maximum height. So the y coordinate of our maximum of our parabola is 55.7. So the maximum height is 55.7 feet. Now, if the performer wants at least 5 feet of vertical height clearance, what we have to do is subtract 5 from his maximum height he can reach to find the maximum height the tent can be. So we have 0.71. So 55.71 minus 5 equals 50.71. So the tent can be no more than about 51 feet. Okay, there's problem 10. Now let's move on to the quadratic application problems. Okay, in number 11 it says the base of a triangle is 4 inches longer than twice its height. If the triangle has an area of 24 inches, what is its height? Okay, the area of a triangle is equal to base times height divided by 2. Okay, and they give us the area as 24, and then we have our base, which they say is twice the height, so 2 times h, plus 4 inches longer. Okay, so we can plug in 2h plus 4 for our base because of that right there. Okay, and then we're going to multiply it by h, the height, and divide it by 2. Okay, in order to get rid of this division by 2, we multiply both sides by 2, and we get 48 equals 2h plus 4 times h. Okay, so we distribute the h, and we end up getting 48 equals 2h squared plus 4h to get rid of our parentheses. And we want to set it in standard form, so we're going to go ahead and bring this 48 over. So we're going to set it equal to 0. So we get 2h squared plus 4h minus 48. And we can go ahead and go to our calculator, go to a calculate page, okay, and hit menu, algebra, and really on your calculator it's going to be menu 331. Remember, our polyroots is menu 331. So the a value of our function was 2. If you go back to and look, you see that it's 2, a is 2, b is positive 4, and c is negative 48. So we're going to put positive 2, positive 4, and negative 48. Hit OK. And then you see our polyroot functions. Double check to make sure your function's okay and hit enter. In the height, they give us the values for h are negative 6 and 4. So h equals negative 6 or h equals 4. And remember, we got that by menu 331. Now, we can't have a negative height, so we are not interested in that negative 6. So our height is 4 inches. Alright, problem 12. We have a rectangular pool that's 24 feet wide and 56 feet long. And it's surrounded by a walkway of uniform width. And we're going to call that uniform width all the way around X. If the total area of the walkway in the pool is 1,953 square feet, how wide is the walkway? So, first of all, we know that area of a rectangle is length times width. So what we need to find, they give us the total area of the pool and the walkway. So we need to find the length and the width. So if we look here, the length is going to be 56 plus 2x. because it's the length of the pool plus the width of x on either side. Okay, so it's 56 plus 2x, and the width is the same way. It's going to be 24 plus 2x because you have the width plus the width of the sidewalk on either side. So area, we're going to plug in the 1,953. We'll plug in our length of 56 plus 2x and our width of 24 plus 2x. We're going to go ahead and FOIL this out, and you end up getting 1,344 when you multiply the first terms together plus 120x. I'm sorry. When you multiply the outside terms together, you end up getting 56 times 2x is 112x. And then the inside terms is 48x, and then the last two terms gives you 4x squared. Combine like terms, and you get 1,344 plus 160x plus 4x squared. Now I'm going to rewrite this to where it's in standard form, so we're going to bring this 1,953 over, and you get 0 equals 4x squared plus 160x minus 609. Okay, and then we're going to go into our polyroot function, remember? So you're going to type in, yours would be menu 331. For some reason, mine's a little different than y'all's. So remember, you're hitting menu 331. And our A value is 4. Our B value is 160. I don't think I did that right. And our C value is negative 609. Hit OK. Hit enter. Okay, and these are the two values that you get for x. You get negative 87 over 2 and 7 over 2. So x equals negative 87 over 2, or x equals 7 over 2. And since we're talking about a width here, with the width of the walkway, x is the width of the walkway, we're not interested in negative numbers. So x is equal to 7 over 2, or x is equal to 3.5 feet. Alright, moving along. Here in 13, we have the product of two consecutive integers is 1,332. What are the two integers? Two consecutive integers can be written as x and x plus 1. And since we're the product of the two, we're multiplying them together, and they have to equal 1,332. We're going to go ahead and distribute this x and solve for the smaller of the two consecutive integers. And we'll get x squared plus x equals 1,332. We're going to bring this 1,332 over, and you get x squared plus x minus 1,332 equals 0. Now I'm actually going to go ahead and write in the word positive. So the product of two positive consecutive integers. Once we have it in standard form, we're going to go to our calculator. And once again, you're going to hit menu 331 in order to get your polyroots. So you're going to go menu 331. I know mine's different. I apologize for confusing y'all, but menu 331 is what you're going to hit. And your A value is 1, your B value is 1, and your C value is negative 1,332. You're going to hit OK, hit enter, and the two values you get are x equals negative 37 and x equals 36. Now, we are not interested in the negative because remember I wrote positive over here, so I'm going to cross out the negative 37. So x is equal to 36, so x plus 1 is equal to 37. And those are my two integers that I'm interested in, 36 and 37. And you can double check by multiplying them together, and you should get 1,332. Last problem, 14. 7 is added to an integer, and that sum is doubled. So I'm going to represent the integer as x, and we add 7 to that integer, And then we're going to take that sum and double it. So when we distribute that, we get 2x plus 14. Okay, when this result is multiplied by the original integer, the product is 396. So the original integer is x, and we multiply it by the result of 2x plus 14. And that should equal 396. We distribute the x, and you get 2x squared plus 14x equals 396. And we need to bring the 396 over. So you get 2x squared plus 14x minus 396 equals 0. Once again, now that it's in standard form, set equal to 0, we're going to go ahead and go back to our calculators, and you're going to hit menu 331. And your A value here is 2. Your B value is 14. And your C value is negative 396. Hit OK. Hit enter. And you get x equals negative 18 and x equals 11. If you read the problem, it wants a positive integer, so x is equal to 11. We are not interested in the negative 18. Okay, so hopefully this helps you and did not confuse you more. If you have any last minute questions, please come see me in the morning at 6:45. Good luck tomorrow on your test, and I'll talk to y'all tomorrow. Bye.